What's up, guys? Today I'm going to be talking about not this 84mm, but the fire system I have for the javelin launcher project. If you don't know what a javelin launcher is, it is this right here. Yeah, it's going to be cool. So let's jump into that intro. So I want to give you guys a heads up on the video you're about to watch. I sort of went crazy. I took about a week off of work so I could get this project done. And in doing so, I did not pay attention and kind of ran wild with the videos I was recording. And I got 3 hours of very boring and meticulous build process that I go through, which in the future, let me know in the comments if you want the full 3 hours of me just going through little bits and pieces of it. But outside of that, I'm going to have to kind of do commentary like I'm talking now over the video, because I need to sort of jump over certain issues to get to the end point of this video, so it's not 3 hours long. I'm aiming for 30 minutes or an hour. Hopefully I can get somewhere in between that, or maybe even less than 30 minutes, but there is a lot to go through. I run through the my gosh, what is it? I run through the, what's it called? I run through the different technical specs of this thing and how everything operates, and then farther in the video I'm going to go over the actual build process, but I'm going to try to condense this down so it's more entertaining and I'm not just talking about little things like this where it's more me. But it was just so many videos and I was tired and wasn't sleeping, and just a week straight of building so I could actually get this thing done. But hopefully I can get all of that condensed down, and I'm also dragging the video out now, so let's jump into the rest of the parts. Okay, I hope you guys are as excited as I am for this project. I have always wanted a javelin missile launcher, but I couldn't get my hands on one, so I decided I was going to make one on a side project, or a side quest for the actual Warlord project, which is this right here, a machine gun mounted on the top of my Forerunner, and I always wanted a javelin on the side of that, like you see in these photos, so I decided for some reason I was going to go make the standalone unit in a full-blown side quest, get that done, and then come back and put that on the vehicle and keep going from there. But we're going to go off of the whiteboard, the different areas we have here. We have 1 through 4. We have the safeties, the firing systems, everything like that. I'm going to go through that, try to explain as much as I possibly can. Most of the time I really don't. I'm really bad at making sure that people understand what I'm doing, and I'm really good at just showing a picture or two, but I'm actually going to go through every single part possible that I can. Okay, so let's talk about the magnetic fire angle safety, which is the MFAS. What this is a credit card size sensor, which essentially has a non-magnetic rod with a free spinning ball bearing. The whole entire thing is free spinning inside of that little credit card space, with a magnet on the bottom and 2 magnetic switches. When the magnet rests over those switches, the whole system can turn on. All of the rest of this has power going to it, and then there's a secondary magnetic switch which has just a green light. There's a battery and a green light, so I know, hey, it's sitting over that, gives you the literal green light, rest of the systems can work. But if you tip that CLU and the tube is at the wrong angle down, that rod, the non-magnetic rod, will now fall away from the magnetic switches, and then the system cannot fire. If you go too far up, the tube will be off and firing at the wrong angle, and it will not fire. Only when the desired angle for the actual system to fire at is achieved, when these magnets have actual current going through it and everything is aligned, will it allow the CLU to go through all the other different functions and actually fire the rocket out. That, like I said before, is hopefully going to be inside of a credit card size space, so I can fit it inside the CLU, and that is all the MFAS does. There's not a single other function that the thing does, just that. So now we can move on. Simulated target lock system. So this isn't a system that is necessary to actually functioning anything on this. I just thought it'd be freaking cool if, as you fire the thing, it makes a 4-tone lock-on sound. Now what this is a servo motor that is swinging an electrical contact over a pad with other electrical contacts. And as it moves around in a circle over these 4 different pads, it makes 3 distinct beeps and then one long beep. It will sound like beep, 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 beep. And then as it gets to the far side of this, it will actually send another signal to the rest of the system. And that is right down here, big old name up there. Now, that system can be taken out. I can shortcut it so I don't need the thing, but I just thought that'd be super cool to have that tone. Now, okay, so now for what everybody has been waiting for, how am I going to actually make this thing look like it is simulating the launch of this missile? With the first stage, as you see here, big old fireball going backwards, and then you have the rocket flying without any thrust because it has that first boost stage rocket motor going off, and then it kicks on with the flight motor and flies away. How am I going to recreate that? Well, I'm going to recreate that, and hold on, with the PEIGSLS. That's a mouthful, which is the Plasma Electric Ignition Gas Simulated Launch System.
What you just said is one of the most insanely idiotic things I have ever heard.
Okay, so I'm going to really quickly go over what each thing is and then tell you the operation. So we have a plasma lighter, a flammable gas tank, a spring and rod. This is the main movement part of the system. Then we have a heavy built-up spring that is just fixed under pressure. And then we have the CO2 tank and actual javelin missile. So the first thing that happens after you cock this whole entire thing back and it sits under pressure, it is released. Upon being released, this plasma lighter stays lit for about 4 seconds. Now, I don't need the whole 4 seconds. I literally need like a quarter or an eighth of a second. It's very fast. But that 4 seconds has got an auto shut off, which helps with power consumption and not burning the whole entire system to the ground. As this moves forward, it hits this flammable gas tank right here, which fires that burst that you see on the Javelin backwards, simulating that first boost phase of the actual missile. Now, this secondary hammer right here has a free moving part, so it will allow just a brief time between the fire going backwards and the rocket going forwards. As this moves forward, hitting this CO2 tank, and the missile will then move out of the tube. So going over that again in more of a fluid kind of way, this rod right here will release, activating this plasma lighter, letting this gas release as this flies forward and hits this. Gas releases backwards. At just a brief moment afterwards, this coiled or built up spring will release, hitting the CO2 tank, firing the missile forward. And then from that point, I have a small delay inside of the actual replica missile itself. So as it leaves the tube, the onboard batteries will then ignite the rocket motor, and hopefully that momentum forward allows the rocket motor, when it's kicked on, not to just flip and fly the missile. Hopefully it will already be stable moving through the air at that point at the angle we are firing at, with the MFAS making sure of that. Hopefully it all will work. I hope that kind of made sense with that big old rundown right there. I have the system sort of built already. As a spoiler, this is all of this kind of put together minus the MFAS and the simulated target system. It's mainly the PEIGSLS, which is already put together. I'm not allowed to fire this thing at this house I'm renting. I've been explicitly told do not fire a simulated rocket booster in the backyard. But to run through this one more time so everybody's sort of with me, the MFAS controls the angle in which is being fired. The simulated target lock system is just for the joy of the operator, getting to simulate locking onto a tank. So this spring moves forward, activating the plasma lighter, letting this flammable gas shoot out the back, releasing this heavy built-up spring, firing this CO2 tank, releasing the missile. The missile then, as it's out of the tube, immediately knows it's out of the tube.
The missile knows where it is at all times. It knows this because it knows where it isn't.
And then that will kick on, firing it up into the air. And hopefully with these model rockets, I'm hoping and kind of betting that those model rockets will be reliable enough to deploy the parachute inside of this at the angle I'm firing it at, so that I can recover the actual rocket and do this over and over and over again, because it's predominantly for films, and the films that we make, I'm trying to get as accurate as possible. It's kind of what set me on this whole entire this journey to make things this accurate and just work as well as they do. But yeah, guys, so that's essentially everything inside of the CLU, the missile, and the tube that make this thing fire. And so far it's working out, like I said, and I don't really think there's anything else I'm going to add to this. So for the most part, this is how it's going to be on the inside. I don't think I'm going to tweak it either. This is roughly how it will be. Okay, so now let's move on to the next part. So what you're seeing right now is actually the PEIGSLS system. That is a very stupid name, I know, but you're seeing the very early test of it. Now, I have this system more or less finished right here. I'm not going to go over it that much in this video, because this is mainly about the external build process of the CLU and the actual javelin tube. In part 2, where I actually go and I start testing this, that will be where I go more into the actual launch system. But I just wanted to kind of show you guys that work for this video, and we'll move on now. So I drew a line on the mailer tube that was the perfect size I needed, and cut down that line till it was the perfect size. Then I cut down the long way you see here, and then overlapped it so I'd have the right diameter of the pipe. Cut a couple other pieces, and lickety split, we're done. Now there's a couple things that I didn't show in there because I actually forgot to film it when I first started this project. Yay. So now we're going to talk about the CLU, which is the Javelin's command launch unit. It's this part right here, in case you're not familiar. This is what I spent the entire week building, perfecting and making sure that this was as accurate as possible. This is the 3 hours of footage I'm going to attempt to condense down. So let's see how good I did. So it's about 12:30 at night. I'm working super hard right now. I have taken the picture that I have of the grips for the Javelin CLU, and I'm putting down on paper, looking at this photo right here and tracing out what I think is the actual size of it, because from what I understand, it is 13 inches deep, 13 inches high, 19 inches wide. So looking at that photo that you see right here and kind of eyeballing, looking at the photo, drawing, looking at the photo, drawing, taking the grips that I think are fairly accurate to size and placing them on the piece of paper on both sides, so I sort of have a better reference point. I cut out the back part of the CLU. The grips you see here will go on each side of the CLU like that. So if you'd imagine it there, and on the other side, so you'd be holding here and here, looking through, tube over your shoulder. All right, so I got both sides of the CLU front and back done. What I'm gonna do is add this mounting bracket. These two holes will mount, or two pegs will mount into the Javelin once I make that mounting system, but they will sit right here. So the Javelin can come back, snap into it, and then lock down, and it's all fallen over. I'm now derailed. I don't know what I was gonna say after that. Moving on. And we are taking a lunch break now. All right, guys, so I want to talk about how I'm going to be mounting the two grips to the CLU and the CLU to the Javelin tube. Because the Javelin tube has actually all of the electronics and the parts that are actually going to launch the rocket, it has a significant amount of weight to it. So I have to use two metal tubes that are connected to each handle. And how this is going to work, through this hole on this side and this hole, this first tube is going to slide through, if you can kind of imagine that going through, so that only these two ends are exposed. This part right here is a support for this tube right here. That tube is going to have this piece of metal that is going to be mounted onto it, or welded onto it, with this mounting hardware that I've made out of two aluminum, gosh, where are they? They're like spacers or washers or something. I got them from a weird project, but they're mounted onto aluminum hardware. And this is going to sit above. This part is going to attach to here. Now, that doesn't make a lot of sense until I actually show you, because I have all these parts laid down because I still haven't welded them together. But once I finally get all this together, I'm going to jump back over and show you guys what this all looks like together right now. Hours have passed. No, we will not skip over hours of time. And in fact, I would like to say a formal apology to every welder out there, or anybody that's ever seen good welds. Because what you're about to see may shock you. You may literally want to die after seeing these welds, and I am so sorry. I don't even know if you could qualify this as a weld. Not even for 1 second will I act like I'm a good welder. This right here, I'm going to be on welds. Please, roast me in the comments. Tell me all the things I did wrong. Put me in a meme. But the metal is stuck together so I can move forward into the project. But look at that, my goodness. Okay guys, so at this point in the project, the days sort of all blurred together. I was staying up until like 2 and 3 in the morning and attempting to wake up at like 5 and 6 o'clock. I wasn't getting a lot of sleep, and I see that there's a lot of stuff in editing this that I just did not record at all for the whole entire mounting thing. Certain areas just weren't there, so Thursday. It's going down. Today, I'm gonna try to get done the entire CLU, the grips, well, I can't do the lenses or anything like that, or any of the daytime optics that they have, but the external stuff I can get done. But I'm gonna try to get that all done today, because I was trying to get that done tomorrow, but there's just so much to do. But I'm actually super happy about this, people. Anyways, yeah, so let's jump into this, guys. This is gonna be a fun one today. All right, so in one of the buckets of random metals and materials that I have, I found this fairly cool mounting bracket for a TV. This would mount against the wall, and it had this rolling part on the inside, and you'd be able to kind of mount your TV whatever direction you wanted. So if you can imagine this, if I bend them up, they'd be bent up like so on one side and on the other side. So I took that part from the TV that mounts up against the wall. I was gonna bend it along this line you see right here and have 2 places of contact, but I realized that it would be easier, and these wings are longer, so I'd be able to get farther out on the pipe or on the tube. But I bent them down like you see there. And what this does, it allows me to put a screw through here, screw through this back end, and a spacer, because it's not completely touching, because I didn't want to bend these all the way in, because then the holes are kind of weirdly aligned. But I'll have a spacer behind this and a spacer behind that, and that will be the mounting bracket for the javelin tube. It's cool how some pieces you find and you're like, I know exactly how to use that, but that's what we got. I'm going to mount it on there, attach it to the CLU, hopefully give you guys a good look at what that looks like. Not 100% sure yet if I'll show you guys until it's done, or show you guys right when I mount this. Who knows? I'm trying to maneuver so you guys can kind of see a little bit better. And yeah, so like I said, grip down, CLU all in here, missile on that side, and then back there would be the crazy PEIGSLS, the Plasma Electric Gas Simulated Launch System would go in the back, and then poof, we have ourselves a javelin tube, CLU, and missile.
Ooh, I'm sorry, baby, I don't mean to be rude. Yeah, I'm just a little different from all these dudes. Okay, they riding waves, me, I'm up on a cruise. Yeah, you feel like me, then you got nothing to prove. I see
It's 11 o'clock. I've been working all day on this, but I finally have the grips for the CLU in place. They have metal rods, if you can see on the top. They go straight through. They're 3 inches long, so with roughly an inch above the tube, so we're looking about 2 inches of depth there. I didn't do the screws going through in front and back to keep that bolt from popping out, but I just put a ton of glue in there, and it's completely sturdy on both sides. We have them in. They are basically perfectly lined up, for the most part kind of eyeballing at the same time. But right here, as you see, are the 2 grips that I just put in. I'm still missing the battery box, the thermal sight in the front of this, and I just need the tube on the side here, but it is coming along pretty well so far. I absolutely love doing this, and this is just super cool in my opinion, but that's what we're looking at so far. It is 9 in the morning. I have myself a burrito. Yes, I'm eating a burrito at 9 in the morning because they're freaking awesome. The morning is still young and I am still tired until I get this whole entire thing down, and then we will jump on it. So this is a grip uncarved down, and then this is the grip that I have carved down. It's rounded on all 4 edges. Like you see, also got the battery box on the bottom. So this is how I'm carving. I'm just taking a razor blade and trying to go at a 45-degree through the whole entire thing, and then kind of changing my angle over and over and over. These grips, it's actually pretty easy to carve because it's just straight lines. One that was super hard to carve, these grips right here, because there's so many random angles. Like you see here, there's this large kind of circle shape right there. Got multiple different types of bends, and I had different heights. So that one was much harder to actually carve into a grip shape. When it comes to these, I just have to go down and round them for the most part, so it's much easier. All right, so I have these bottom parts of the grips done. I will show you the reference photo I have right here. I'm just actually have a ton of reference photos for this bottom part and everything in the project, but I thought actually it was going to be a very hard part to get done. But since this is an actual piece of military equipment that I'm basing this off of, they literally just like took a flat bar, attached it, and then bent it into position. So all I did was the same thing. I took the flat bar, glued it into place, not a flat bar but paper, and then I put in this twist, and then it becomes flat at the bottom, you see here, and then I had it in 2 pieces. So then from here, took it flat across, bent it. It has a little bit of a cant in there. You can barely see it on this short end, and then it flattens across, and that's all they did for that, which is super cool because it allowed me to fairly accurately copy that. And I'm thinking that's pretty freaking awesome, because now the bottom part of the CLU is for the most part done. I still need to add the front of the battery part, and then attach all the different lenses on the front, then put in the foam protection that it has around, and then we're cooking with bacon at that point. So I have the trigger in place, working pretty well, and then what happens up here is the trigger has a little screw popping out the top that activates the micro switch, which sends the power back into the main CLU. This button right here just allows the circuit to complete. It's technically my safety. If you're going to fire this, you have to press this red button, pull this trigger, and then it allows what is inside of the CLU to activate the little rocket in the back. I got a considerable amount of stuff done on the CLU. Right here on these different circles is where the actual large thermal unit is going to go. The inner ring is where the bottom of the cone is going to sit, and the outer ring is going to be the top of the cone, and the outer ring is most likely where the walls of that thermal lens will go. I got the different covers. I don't know what these things are called, but they're like the control unit there where the buttons are in the back. I have those set. Got a couple bolts in it right there. I'm still missing the back part for the actual screw to fit into there, but it's looking pretty cool so far. Everything is fitting together. That's everything I've got so far. If you were looking at the photos, I wish I had a real one to really model this after, but it's coming along pretty well. Nitro! All right, so it is Saturday morning. I've got quite a lot of stuff done for the javelin project, but today I'm going to be working on shaping this foam. These parts right here that you see on the javelin, almost all of the front, the back, not even almost all of it, those pads that you see around the back of the tube, front of the tube, and around the CLU are all foam. I don't think a lot of people know that, but that's actually like it's almost like a rubberized styrofoam. You can see the the texture pattern on them. They're the large kind of balls of styrofoam. But also to give you guys another update, I have now the heck was that? I'm derailed right there. I have the front thermal cup on there. That's cool. Not the thermal cup, but the thermal housing. So I don't have a thermal, but we're getting there. We're getting there. It's looking like a CLU every single day. All right, so this is a little bit difficult to explain because my phone that I'm doing this off of is actually recording me, so I will kind of demonstrate what I'm doing to get the foam pieces right. This photo right here is what I am using, and I'm looking at each individual piece, where it sits, looking at the bottom of the foam. Hey, where does it fit on this bottom corner? How high does it go compared to the tube? How far does it go out? What's the angle coming back down? How far does it go down? And I'm kind of trying to adjust all of those parameters to where it looks best with the measurements and size that I have with this tube, because they're not going to be one-to-one, so I can't exactly just go, oh, from here to that point, because my tube may be a little bit higher. My mounting system may be a little bit different. So what I'm doing, like I said, I'm looking at the bottom, and I'm trying to always go off of what I kind of deem is the most important part. Like, okay, so this part is the most exposed. For me, it was this bottom area going across that you see on the photo. If I can get that part right, then everything else can kind of be off. But if this straight line going across is off from the bottom of the CLU, the most exposed part of it, you're gonna tell immediately. But if this angle up here, going from this corner to the tube, is off, that's gonna be much different because it's already at an angle. And usually when people actually look at these things, they're not paying attention to kind of angles that are bent. They're looking for horizontal and vertical lines that are off. Those lines you kind of have to get right. But everything at like a 45, a 60, a 29, all those different types of angles, it doesn't really matter necessarily to get them slightly off, because when you're looking at them with your eyes, you can't tell if it's, oh, it's not a 45, it's a 46. But you can tell, man. If something's not 90, you can tell. So what I'm doing is taking a piece of paper. I already have my straight edge of the paper because it's already perfectly straight that way. And I'm putting it against like so. And then I'm marking an area. And then I'm going, okay, that looks right with the photo. And then I'm coming back down an angle, and I'm drawing that kind of area. And then I'm taking my square, making sure everything is sort of, not the square for the square part of it, but actually just a straight line. And then once I get that front part cut out, then I will turn this sideways and do the same thing down the tube, straight down, and then a 90-degree line back. And I'll kind of keep doing that until I'm like, okay, I like that angle. And then I will take it to the foam, and I will cut out all of those different angles and things with the foam, and then I will attach it, and then I'll figure out what I need to cut out on the inside. And luckily, since you don't see the inside, I can just drill out a circle hole and fit the thing on. But those are the kind of ways that I've incorporated building over the years, and different ways to do things. I'm not the biggest fan of using computers and stuff like that, because I really want to know how each individual part, process, material, all those things work together. I don't necessarily want to do it on a computer and then just be like, okay, yeah, everything perfectly fits. I want to know how to get that to fit by hand. That's just a me thing. I think there's a lot of benefit in computers and stuff like that, but I just don't want to use them. So that's what I'm doing. All right, so this piece of paper right here is going to represent, for now, the foam part of the javelin, as you can see right here. And now what I'll do is I'll lay that on the foam, and then I will cut that front part out, probably all the way in with the same pattern through, depending on how much foam I have in that direction. And then I will sideways cut as far down as I need, and then bottom cut and all those different things. And then inside I will hollow it out and lay it in there and do all the finishing touches. So good news and some bad news. The bad news is the hot glue gun that I have is a high temp hot glue gun. So when you glue the foam together to itself, both pieces of the foam want to recede from each other, and then you no longer have them stick together. But the glue sticks to the foam very well, as you can see in there. There's no getting those apart without the foam ripping from it. Now, the good news is that when you glue a piece of paper or wood or something that doesn't absorb the heat in the same way, the foam sticks to it very well. As you can see in here, there's no getting those apart without it tearing, which is exactly what I want, which means what I'm going to have to do is that I'm taking these foam blocks and gluing them together to make a big enough piece, I'm probably going to have to put a piece of paper in between at certain areas that I can glue together to keep them from separating in that way, which means the project can move forward from this point. I was kind of getting worried because I was like, if I can't get hot glue to fix or to stick together, and I can't get super glue to stick together, I don't know what else to do except for go out and get some really long cure time shoe goo, which is basically like a goo substance of glue that sticks to things like this, but that takes forever to cure, and I like stuff that cures instantly. So moving on to the next thing. All right, so what I found is I need to actually put the glue on a piece of paper and kind of blow on it until it cools down. And once it cools down enough and it's not super high temp like it is, then I can place the foam on it on one sheet of paper and then flip it over and do the same again. It's when the hot glue is so hot it just burns through everything. So that's what I have found out in the little bit of testing that I just did. All right, so I have the very rough cuts done, kind of making it the angle it's supposed to be from every different side. It's gonna fit right inside of there, underneath the javelin. Still looking kind of weird. Well, not weird necessarily, but it's looking odd with these strange cuts and unfinished everything in the paper I put in there. It just looks ugly. But once I finish this up, it will look beautiful. So even though I still have to paint the CLU and get a couple things done from here, I'm going to glue on the foam pads to this because I don't really think it's not going to interfere from what I can tell. From here on out, most of the external stuff is done. I still don't have the lens for the actual thermal unit, which I will not be putting into this because I don't want to spend 10 grand on a thermal that will fit in here, and I'm pretty sure the one that goes in the real one is more than 10 grand. But the only things I really have to do is fill in a couple areas here and put in the other unit on the other side. And because of that, and me being so close to being done with this, I don't really think it's going to interfere, like I said. So I'm going to go ahead and glue this on. Hopefully the rocket flies. That's the part I'm waiting for in anticipation. Okay, so time is on my side when it comes to this because the glue is too hot to bind to the foam without melting through it. So this will allow me to glue most of it, let it cool for a couple seconds, and then force apply that on, and hopefully that doesn't come off. I don't think it will.
Have you ever met Miss Lindy? She's a gal with the bright red hair. Now she stands high from all the rest. You know her anywhere.
The thing I'm finding about foam also is it seems that since it's so insulated when it comes to the fact that it's just full of air, seems that when you actually put this glue on there, it takes longer to dry or longer to cool because that insulation is keeping in the heat. Random ramblings. That's looking good. That's looking good. That's looking good. So it looks like these other parts that I'll be putting on the CLU when it comes to foam will be much easier because I'm not making a solid block. I can actually just hand cut each piece and tailor it to fit or customize it to fit where it needs to go over each area, and that should be much easier than doing it the other way. The unfortunate thing is, since this one has about half a foot out of just foam unsupported, I'm gonna have to put in some sort of rod system inside of the foam so something pushes on it, it doesn't just break that piece off, but it'll have a little bit resistance. So the system will have to be a little bit, I guess, handled with care. It's pretty solid up until this point, but those foam pieces, because I'm not using the same foam that you would that's like military grade, like hard rubberized foam, I'm gonna have to do it that way. So update in a couple seconds. So I have the directional cut. It's working out pretty well. I still have to glue them together. They are not held on by anything other than tension. I just wanted to show you guys how good this locks up. Oh shoot, look at that. what the javelin looks like on my shoulder. I think this came out really freaking well. I still don't have all the little pieces on the front. I have the lens cap for the front, but I don't have the hinge mechanism put in yet. Little pieces on the front that I haven't put together, but I just want to give you guys, for part one, the look of the thing and how it's actually working together so far. I think, like I said, this is looking really good for a first time trying to actually attempt building this javelin. I have built other launchers. You see the 84 behind me. I'm probably going to color match these two together because I think the color that I got for the 84 millimeter was actually like on point. But when it comes to this javelin, I'm super excited because, like I said, always wanted a javelin, and this is it's like a dream come true. So now, in part two, what I'm going to be doing is going over all the technical stuff, and it's actually in the way that it's going to work. I'm going to be going over the firing system, the actual rocket, deployable fins, all the testing, and then all the cool stuff comes in part two. This is just the part where I wanted to show you guys kind of my build process, a little bit about it, and show you guys the actual thing working so far. But yeah, like I said, it is looking pretty good, and I want to say thank you guys so much for subscribing, following, and keeping your attention this long into the video. I think it's like 34 or 37 minutes, but thank you guys so much for the support and everything like that, and I will catch you in part two where we finally get to make this thing actually fire and all that cool stuff. That's what I'm super excited for, so I'll see you guys then.